We'll now get our hands on Julia, and we'll start with the introduction to Julia. Julia Language Context and Basic Concepts by Mrs. Iga.
Iga Szczesniak.
It's been almost 2 years and I still can't spell it. And Mr. Júlio Hoffimann. So Iga is a project developer at the Earth Observation Laboratory of the Earth Center. She holds a master's degree in geoinformatics, photogrammetry, and remote sensing obtained from the University of Science and Technology. Of your university?
Of Science and Technology.
Oh.
Yeah.
Iga is involved in the implementation of projects using Earth observation data and the Internet of Things, as well as the Julia programming language. Furthermore, she's interested in the commercialization of technology and sustainable development. Currently, she's pursuing a master's program in space entrepreneurship at the European Institute for Innovation and Sustainability. I will already introduce Dr. Hoffimann. He has more than 10 years of experience developing advanced statistical software for geosciences. He's a creator and lead developer of the geostats.jl framework, as well as various other open source projects that are widely used by the Julia language community. His career goals include, first, advancing the field of machine learning and artificial intelligence to account for challenges that are unique to geosciences. Second, establishing new methodologies for uncertainty, quantification, and decision-making involving the use of natural resources in the planet. And to achieve these goals, he founded Arpeggio, a software company that offers consulting services and high-performance products written in Julia. Thank you very much.
Thanks, Mariana.
Okay. Okay, so let's start. Hello, everyone. First of all, thanks a lot for coming. My name is Iga, and I'm a project developer at the Earth Center. And today I will give you a gentle introduction to the Julia language, just to make sure that everyone here in the room is at the same page, and we will not have any problems with the Julia installation and understanding of the syntax later on. If you read my email that I sent on the Friday, you should have at this point downloaded Julia, at least version 1.9 on your computers, and Visual Studio Code, or if you are using any other editor, that's also fine. It's up to you. And if you still didn't, just please download it and go back to the links that I sent. And we are going to work with the notebook that you can find on the GitHub repository for the workshop. The GitHub repository you can find on the workshop website, and then there is a link. You basically clone this repo on your computers, and you can open it in the Visual Studio Code. So once you are downloading, let's talk about the Julia context, and I will present a few facts about the Julia. So it is relatively a new language. It was created in 2012 at the Massachusetts Institute of Technology, and the first version was released in 2018, and the latest version is Julia 1.10, and it has been released in December last year.
Can I interrupt you?
Yeah.
So hi everyone, my name is Júlio. I'm with Iga here in this presentation. So my role here is I'll be passing through the table. If you have any issues with the installation or anything, I'll be supporting the presentation. So just raise your hand if you have issues.
If you have any questions on the way, just ask, and we will be here to help you, like to make this code running for you. And later on the afternoon, you will not have problems. Yeah. So Julia is an open source language. It has a high level syntax and is known for the high performance and high speed. It is known that it solves the so-called two-language problem. So it is fast as the C language and has a user-friendly syntax like Python or MATLAB. Julia is a dynamically typed language and just-in-time compiled, and it supports parallel computing as well. So this is another advantage. Julia is a good option for all kinds of data science applications and technical computing and the scientific machine learning. From the Earth observation perspective, it is a nice ecosystem to work with because it is good for the heavy data sets such as those generated by the Earth observation satellites, the clouds of points and stuff. So it has a better performance than Python in some cases. So I hope you at this point have downloaded the notebook and open it. Is anyone having a problem? So I will start just running this. So to check out the info version, you basically use the version info function or simply write a version and you can access this information. The first thing that you may want to do is defining variables. So to define a variable, you basically write a variable name and then assign a value to this. When your variable is a string, you need to use brackets. And when it is numeric, you simply write it as it is. Can you maybe maximize? Yeah. Is the size good? Okay. To check out the type of your variable.
Maybe you need to command plus to increase the.
Command plus more.
Yeah.
Okay. Is the size good for you right now, or more?
I think you will never be before you. You have to follow the screen. Yeah, you have to see it on the screen.
Okay.
No way there.
So yeah, to get information about the type of your variable, we simply use the type of function, and here our variables were string and integer. We can convert the variables from one type to another, and here we are going to convert the integer to float. So for the printing, we are going to use the println function, and we can use the $sign to insert the existing variables into strings. We can use the asterisk sign for concatenation of the strings. So if we want to merge them together, we are going to use this. The math syntax is super easy. You will see it's very intuitive, and it goes like this. Then when we start working with many variables around, it is better to store them in structures. So in Julia, we can define the custom structures with the struct, and they can store the multiple pieces of data in a one format, kind of. And then we need to remember that structs are immutable, so it means that when we assign value to them, then we cannot change them later. Here we are going to create a struct called location, and to access the field names of this struct, we are going to use the field names function. We see that the struct has a name, latitude, longitude, and information whether it is an island or not. We are going to test it for Tessera. It works, and then Paris also works. Then, on the other hand, if we want to update any of these fields, we are going to use a mutable struct, and we can define it in Julia using a mutable struct and keywords. We are going to test it for Terceira and update the field name to be an area code basically instead of the full name, and we see that it is updated. Okay, perfect. Then we have native data structures in Julia. First, it's tuples. Tuples are order sequences of elements, and they allow indexing, so we can access them by order. But we need to remember they are immutable, so we cannot update their fields later on. We are going to create a mytuple example and access it by element. We can store in these tuples different types of elements. Here we have the integer, string, and float. And just one remark, Julia is a one-base indexing, not zero-base like Python. So if you want to access the first element, you basically write 1 instead of 0, for those of you who are used to Python. And then we have a name tuples. They are basically like a regular tuples, but they assign name to each element. And then we can call these elements by order or by name. And check the type of name tuple as well. Dictionaries. Dictionaries, they can store data sets that are related to each other. So for example, a contacts list, like you assign a certain person to a certain phone number, and they are mutable, so we can update their fields, but we cannot index into them. So let's create the example dictionary and access it by person. We can add another entry to the dictionary like this, and we see that it updated. To remove elements from a dictionary, we are going to use the pop function with an exclamation mark. I will explain what is this exclamation mark later on, but for now, let's see that it is removing. All right. However, we cannot update their fields if we once assign it. So then we have arrays. They are both mutable and order, so it means we can update their fields and index into them. Let's create the example array of the best movies and access the first best movie, which is Harry Potter. We can update it to be The Godfather, for example, and we see that it is updated. We can edit our arrays and add elements and remove them with push and pop functions. And push is adding a new element, and then pop is removing. We see that it removed. And yeah, arrays can have any number of dimensions, and they can store other arrays as well. The common arrays that you may work with are zeros and ones, so you can use these functions to create them. For the concatenation of the arrays, we can use the cat function. This is a built-in function in Julia, and it works like this. When we have two vectors, we can concatenate them along the first dimension with this result, and then along the second dimension is giving this result. Alternatively, to get those, we can use vcat and hcat functions, and then we don't need to specify these dimensions. So for the array inspection, we can use ltype function to see the elements type. Then we are going to use length to get the total number of elements of the array, endims to get the number of dimensions, and we can check out the size. We can do indexing on vectors and matrices. First, let's do for the vector, so we can access its third element in this way. we can access the last element of the vector by using AND. For the matrix, if we want to access a certain element, for, let's say, the second row and the first column, we are going to write it like this. For the slicing of vectors and matrices, we are going to use colon, and then we access all elements from the second until the fourth elements. Yeah. And for the matrix, if we want to access the second row, then we first specify this row and then use colon. Yeah, we can add we can manipulate our arrays and, for example, add another value or the entire row, and then it updates. For the multiplication, let's first create a random matrix called A, and the vectors filled with ones. We can multiplicate them by using the asterisk. For the transposition, we are basically using the apostrophe, or there is another function called transpose, and it's giving the same result. And we can multiplicate two matrices like this. Then we have loops. The syntax for a while loop in Julia is the following. We can use it, for example, to iterate elements over an array. And then we have a for loop. We could use it for the same. And there are two ways. We can use in, or we can use the element of symbol instead. And then we have a conditionals. Let's try to write an example conditional statement that prints a number if the number is even, and then it prints the string odd if the number is odd. We can do this with the following code, and alternatively we can rewrite it with using the ternary operators, and then it's going to be just one line of the code. And this is a more Julia way to write the conditional statement, I would say. To define, we can define the functions in different ways. The basic syntax to define the function is by using function and end keywords. And let's define a function that prints "Hi, it's great to see you," and test it. And then we define a function that calculates the square of the number, and we see that it works. Alternatively, we could declare these functions in just a single line like this, and they are giving the same results. Or we could have declared them as the anonymous function, and then we need to use the arrow, and it is giving same result. And now it's a little exercise for you. You can play around with declaring the function and try to make a function that prints "Hello Julia" if the given name is Julia, and then prints "Hello World" if the given name is different. And you can do this, and below there is an answer. And now let's talk about the difference between the mutating and the non-mutating functions. So let's see this difference for the example function sort that sorts the elements of the array. So we create a vector and apply this sort function into this, and we see that it orders ascending way. However, if we access the, if we want to see the variable again, it is not updated. So to perform a mutation on its arguments, we are going to use the exclamation mark. And if we apply it to the sort function, then it changes the original variable. Then we have a broadcasting. This is a technique that we can use to apply a function to each element of an array or a collection without using the loops. We declare before we have declared the function that calculates the square of the number, and we are going to apply the broadcasting, and then it is applying to all elements of this. And alternatively, we could multiply each element of the matrix by the scalar with the broadcasting. So let's define the matrix and the scalar, and the result is like this. The broadcasting is applying this dot before the multiplication sign. Okay. Then we have multiple dispatch. This is a key feature of Julia that makes the code fast and generic. So as we discussed before, Julia is a dynamically typed language, and it means that we don't need to specify the type of the input argument when we declare a function. This is optional because Julia does it on the fly. However, we can we can still specify this type. And if we create a function called add and then specify the type of its arguments x and y as integers, we can later create exactly the same function with another type, and then it doesn't mean that we rewrite or replace any of these functions. It's just we add another method to the generic function called add, and it works for both types of data. So here we have the result for the integers and the result for the floats. If we want to see how many methods we have assigned to the function, then we are going to use the methods. And we see there are two methods for the generic function add. To see which method is being dispatched, we are going to use add which, and then write the function. All right. Another advantage of Julia is that it has a built-in package manager called pkg, and this is eliminating the need for external tools like Anaconda, for example. And the basic application of this package manager is for installing and uninstalling the packages, creating the environments, and dealing with the dependencies. So to start using this package manager, we basically need to write the keyword using and then pkg. And to see the package's status, we are going to use pkg.status and the parentheses. And we have a list of which packages are downloaded in here. To activate the environment, we are going to use pkg activate. And we need to remember that first time, if we are using the package on a certain Julia application installation, then we need to add this package, and we can add the packages with pkg.add, and then we are specifying the package name like this. All right. We are adding a bunch of packages that we are going to use later in the hands-on, and every time we use Julia, first time we need to load these packages with the using keyword. So to start using, for example, package called data frames, we need to write this keyword using and then data frames, the name of the package. All right, so now we are going to work a little bit with the tabular data, and I'm sure that every one of you at some point work with the tabular data, and this is useful for everyone. And the kind of basic packages to work with this are csv.jl, downloads, data frames, and the statistics. And now we are going to explore some of their features. I would like to open the notebook called Exercise 1, and we are going to run it. It's in the same folder that you downloaded from GitHub. So in this hands-on, we are going to see the performance of the Internet of Things sensors that we have installed on Terceira Island. They are measuring for us data like temperature and humidity every hour. And we are going to compare them with the National Meteorological Station called IPMA. So these data are coming in a CSV format, and I'm going to use those packages, CSV, data frames, downloads, and the statistics to play around a little bit. We are going to load the data for the two sensors, and then for the two IoT sensors, and then for the meteorological reference station, and then calculate the correlation. So first, if we want to read the CSV file, we are going to use the csv.jl package and the read function. It's really straightforward. We just need to specify the path where we store our data, and then the data type. And I'm using the data frames here. By the way, to not print all of the records, we are going to use the colon in the end of the line, and then it doesn't print. To get a quick preview of data, we can narrow it down to display only 10 first records, and then it is like this. So we have our data downloaded over there. We see that it has a bunch of columns like timestamp, the station ID, some meteorological variables, and we also notice some missing values in it that we want to remove. And now I'm gonna select the columns of my interest. And we can do this with the select functions from the dataframes.jl. And I'm using the exclamation mark syntax to actually update my table. So, to access the names of the columns for this data frame, I can use the names function and then specify the variable. Okay, then we are going to download the data for another sensors from the internet. We can download it using the downloads.jl package. And first we specify the path, the web link, and then the path where we want to store it on our machines. So then I'm gonna read this data again with the csv.jl and select columns that I'm interested in. So before we did select the columns that we want to keep, and now we are going to select the columns that we want to exclude. So it is the other way around. To join two tables, we basically use the join function that is included in the data frames package. It has different types of joins, like the left join, right join, semi-join, inner join, outer join, and you can basically choose which ones are good for your data. Here I'm going to use the left join. And we have our tables joined over there. However, there is some missing values in our data set, and normally we would like to remove them. So to remove the missing values, we are going to use the drop missing function. And now we have it removed. And at some point, when we did all of those modifications in our tables, we want to write it back to the CSV file again. And we can do this with the CSV package again with the write function. And it's like this. And now I'm going to calculate the mean values of temperature and humidity. And for this, and add an additional column to the data frame. So for this, I'm going to use the mean function from the statistics.jl package, and it calculates those mean values. And to add a new column to the data frame, we can use the following. We calculate the correlation coefficients for the both variables like temperature and humidity, and round them to 2 decimal places. To get the number of observations or the number of rows, we can use the size function, and we have in our table 3,236 records right now. Then the useful functions are minimum and maximum, and they work for the dates as well. So our data is actually around 1 year of the time window. And now it's the time to visualize this data to get some more insights. And for this, I am using Maki.jl, and its backend for the scientific plotting called Cairo-Maki. However, you can use others, like other frameworks like plots. It's up to you. And I'm going to plot this data from 2 IoT sensors. Actually, we can add the title, the X and Y labels, change the color, the size of the plot, and it's up to you. I will add the information about the correlation coefficient and the number of observations. I think it is a good idea. And the correlation for the humidity was 0.77. Which is not that bad. And now let's see how these measurements look like compared to each other. So I'm going to plot it with the lines plot, and we can see nicely the differences between the both sensors for the humidity. Now let's see everything for the temperature. The correlation of the temperature was better, was 0.92, and if we see the measurements, we can notice that in the beginning it was really great coverage, but then it was some shift later on. It will be interesting to compare those mean values with the national reference station. So I'm going to repeat those steps and read the data for the reference station and update the tables. I'm calculating the correlation coefficients, and here we got the values of the correlation coefficient between mean values for the IoT sensors and the reference meteorological station. It was actually really good, 0.98. I can play a little bit with the layout and visualize both plots next to each other. So we see that definitely in the beginning the coverage was great, and then it was some shift. Now I'm going to do the same for the humidity. which was not that great as the temperature. The correlation was 0.74, and I'm plotting here the correlation and the measurements next to each other. And it is like this. So the one cool finding is that the LoRaWAN low-cost sensors have a better performance for the temperature than the humidity. Now let's go back to the main notebook. I'm going to skip all this part about the tabular data because we just did this hands-on, but you can take a look afterwards if you want to. And just to remark, I wanted to add where to seek help if you have any problems with your code or find any bug. Actually, Julia has a really great user community, and people are really friendly and want to help you. And it has really fast-growing community. So every year there are newcomers, and it's always good time to start. And the main help desk channels to seek help is a discourse forum and the Julia Slack. And there is a bonus for those who are working with geospatial data. There is a Julia Geo channel. So for specifically problems related to this spatial data, I would recommend to reach out there. And if you have any problem, you can always open an issue on GitHub, and then it will help the developers to find the bug and fix it later on. And that's all for the introduction. I hope you were able to run it, everyone. And then on the afternoon, we are going to have more advanced sessions, and I hope you will be ready.